Yes, good morning, everyone. So today's welcome to SAP Sessions. Today's session going to be 181 and 82. We will start a new topic, that is working with the procedures. Under procedures, we have to discuss three procedures are there in ABAP, seeing subroutines, function models, and methods. Okay. So here now I will discuss subroutines and function models first. Okay, later we'll go for methods and oops concepts. Okay. So quick revision. We have done the basic introduction, architecture, dictionary, programming. Under programming, basics over. After basics, we have done the complex data objects as a set of discussion, working with complex data objects, correct? Right. Next, we are into the modularization techniques. Under modularization techniques, first I introduced what exactly the modularity and again advantages of modularity. Yes. And again source code modules and as well as procedures. Okay. Right. So what is macro is and what exactly includes concept over. Now we are into the subroutine. Yes. Okay. Subroutines. Okay. Also called as okay. Subroutines also called as routines also. Okay, routine or subroutine both are same, or sometimes we are going to call it as forms also. Because okay, in some context point of view. So we have to understand this. So subroutine, subroutines, basic introduction we will discuss. Okay. In today's topic. Okay. Basic introduction we will. Right. If you go to the subroutine is a procedure. Okay. So procedure concept is procedure definition. Procedure must be defined first, and as well as procedure must be called next. So in with respect to subroutine point of view, like how do we define subroutine? Subroutine is a procedure. Subroutine is a procedure which is defined which begins with the form keyword and ends with the end form keyword. End form keyword. Okay. Right. That is the overall subroutine basic this thing. So now form and form. Subroutine is a uh, subroutine is a set of statements or collection of statements or collection of statements between form and end form. Okay. Form and end form. Right. Right. So now just we'll go for syntax to define subroutine. Directly we'll go to syntax. So as I said, it begins with form, FORM, form space, subroutine name, form space, subroutine name, then end form. Form space, subroutine name, then end form. So in between, we have set of statements or collection of statements. Okay, right. Right, form space, subroutine. Subroutine, okay, because it is a subroutines are mainly used for local modularization purpose. That is the main functionality. So local modularization means subroutine is defined and called within same program. So advantage of, yes, advantages are like this. First, what are the advantages? First, day one itself explained. Yes. So subroutine definition exist means available at one place. Subroutine definition exists at one place, and it can be called several times. It can be called several times. Yes. That means calling statement. So calling statement exists multiple times. It may exist. May exist multiple times. Multiple times. Right. That's about overall. Yes. Advantages, as earlier discussed, code reusability. Reusability of the code. Then again, avoiding code redundancy, duplication. This is already discussed. Okay, redundancy. Then after that, improve the transparency. Improves the transparency, code transparent. Okay. Yes. So this is all about your overall subroutine related basic basic statement. Now, okay, perform statement. Perform statement is used to call subroutine. So now syntax. Syntax goes in this. That is perform space subroutine. Perform space subroutine name. That's about like so what exactly the fundamental rule here is mm, perform statement. Okay, that is calling statement. Okay, must exist before, okay, subroutine definition. That is, this is opposite to the macros. Macro concept, first subroutine definition, then calling. But here it is Opposite. First perform, then later subroutine name. Okay. Subroutine definition. Yes. Perform statement must exist before subroutine definition. Right. Then, as a rule, I'm going to extend this statement. We'll go to each line for practical purpose also. All perform statements exist at the beginning, at the beginning of the program. Okay. And all subroutine definitions exist at the end of the program. At the end of the program. Because, yes. Okay. So after subroutine definition, that is after end form, another subroutine definition is accepted, but general statements not accepted. So each thing I'll explain to you practically, then only you'll understand this basic. General statements not accepted. Okay, because immediately it will give error. So let us go to practicals, whatever being discussed till now. Okay. Right. You see 38. AVK underscore program underscore subroutine. Okay. Subroutines. Directly, program itself is meant for subroutine. So the title of the program working with subroutines. Okay. This is very, very, very important topic. Nowadays, everywhere SAP developers used subroutines everywhere. Even we are also going to use subroutines everywhere in our program it is a part of modularization technique. So let's go to the save as normal program, save as local object package, continue. Now, like this is your program name, isn't it? Here we have to discuss, suppose, first fundamental question. So form space, okay, form space, subroutine 1, okay, sub 1, just that is the name of the subroutine. End form. Yes. Observe the basic topic. So form and form. Now this is accepted. Okay. Suppose by mistake I forgot mentioning form. Then you'll get a message as incorrect nesting not correct. The statement and form does not have open control structure starting with form. So that is, this subroutine is also considered as a control structure. Okay. So I will go with the opposite way. Yes, opposite is end form. Sometimes we miss I forgot to mention the end form. Okay. So you can observe incorrect nesting before the end of the program. The control structure introduced by form must be closed by end of form. These both are most important. Okay. form and end form. Right. Yes, this is okay. The name of the subroutine. Subroutine name, okay. Yes. Subroutine name can be begins with some F underscore, we will write it. Okay, that is, or S underscore also sometimes, subroutine underscore. Okay. But there is no special nomenclature because it is a part of the program. Inside program, you can go with anything. That's why I just named as sub one. Okay, clear? Okay, fine. Then next, in between, form and form, between form sub two and end form. This is not allowed. So nested subroutines are not allowed. Nested means one subroutine and another subroutine. Yes, very important. Nested subroutines not allowed. Okay. Yes, that is, we cannot place one subroutine definition under another, okay, under another subroutine definition. Okay. No, nested subroutines not allowed. Yes, but one subroutine, mm, one subroutine definition may call another subroutine. Another subroutine. This is possible. Yes, self-calling. Self-calling is also not possible. That is recursion. Recursion. Recursive calling. Okay, recursive calling leads to runtime error. First of all, what is the both statements contradict? I will tell you practical. Let us go to the yes. Okay, this is nesting concept is over. Right. So here form is the beginning keyword or starting keyword, end form is the ending keyword. End form is one keyword, end form. Okay, no space. Like, so this is your basic, yes. I'm going to write it here as defining subroutine. That is the base. Now here inside, you can write n number of lines, but I will write only test subroutine sub one statement simply. Okay. Now see, now it is syntactically correct. No errors. Correct, no errors found. But even though no output also. Yes. Even if I press F8, no out. The reason is subroutine must be called. Okay. Subroutine is not self-executable. Like it must be called explicitly by using perform statement. Okay. Hope you are clear with this. So subroutine is not self-executable. So at least, okay, at least one perform statement is required to call subroutine. At least one means it can be one or n. That is, you can call a number of times, but at least one is required. So as I said, subroutine, first the calling statement. Yes. Calling subroutine. Subroutine can be called by perform space subroutine 1. Perform space subroutine. Now you go for save, check and activate and test. Now test sub 1 statement or subroutine statement. Okay. So if you go to debugger, once program menu execute debugging, just I'm going to debugger directly, how it is working. So observe now, okay, we are into, this is the program name. Same program name is mentioned here. Even main program also, a current cursor position where it is. Okay. So now first statement is perform. Okay, perform. So perform sub 1. Like can I see sub 1 is not a variable, it is not a structure, it is unknown variable. See, it is not invalid variable. Okay. Subroutine is a procedure. Yes, it doesn't have any memory and all to evaluate and all, right? But in debugger advantage is that the line by line execution flow you can check. When system look at perform statement, perform sub 1, then it looks control immediately transfer to the subroutine definition. Subroutine definition. See, subroutine definition. Like now, it will execute all the statements till end form. It will execute all the statement till end form. Done. Over. After end form ends the subroutine. Is there any other statement? No. It will go to the output. This is the basic topic. Then we will go to back. Can I call this subroutine again? Uline again perform space subroutine 2. Perform space subroutine 2. Subroutine 2 does not exist. Immediately you will get an error stating that subroutine 2 does not exist. That means what is mandatory? Okay, subroutine must exist before calling. Okay, if you want to call it, its definition must exist. That is one of the rule. Okay, we will go to, after few minutes, we'll come back to the topic. I'm trying to call the same again. Right. Perform sub 1. That is calling the same subroutine again and again. So if you execute, it is giving the output this way. So I will go back to this one, execute debugging, because here it is, what are the things you can notice it in debugger point of view. First of all, the subroutine, where can I find this subroutine? Because it is no memory allocated for as a table or object or this one, variables under this. But here there is one more section called as event startup selection. But I have not typed anywhere startup selection, isn't it? But still system is showing event as startup selection. That is implicit event. Then if you come to here, yes, you can see still event startup selection. But after perform, statement perform is a calling statement for subroutine, control transfer to subroutine. Right. Sub 1. Now you have to see when cursor is here. When cursor is here, you have to see the event is replaced by form. Event is replaced by form. Now form/form name. This is your 15 is the current cursor position line. So it will execute till last end form. End form ends the subroutine, isn't it? Yes, after that F5. Now we are back to U line again. When cursor is coming to this way, I'm calling it as a calling zone, calling area. Okay, this is subroutine definition area. So you have to see when cursor is at a calling area, it is showing the event name. When cursor is there at the subroutine again, yes, in the debugger, it is showing the name of the subroutine. Name of the subroutine. But we cannot write notes for everything. This is your understanding sake. How you can explore the debugger. Okay, got it? The second. So what I said, that is true. Subroutine exists at one place, definition, and the next subroutine definition exists at one place. But calling statement can exist multiple times. So, first of all, as I said, what is the need of this? What is the need of this? This is the need. If I go to write statement, write test subroutine, same thing, copy paste. Okay. So this is my write statement. After that, I will write you. So after that, I will write uline statement. Again, this is copy and paste. Okay. Again, skip statement. Again, copy and paste. So this is called as, okay, hard coded statement. That is, same code appears more than once in the program. That is not recommended. So how do you modularize this? By using routine or subroutines or forms. That is, simply, what is the confusion? Confusion to the developer is why the code appears twice. What is happening overall? See, if it is one line, we can catch it. One line, it's okay. But 10 lines, 10 lines, 10 lines. Repeatedly, we write 10 lines again and again. That leads to a confusion to the developer. Correct? That's why I'm going to comment it. So, because yes, that actually our requirement begins how you can modelize this. You can modelize in this way. You can go with, that is the above line is before modularization, this appears. But the same thing, if you want to do it, yes, you can go for, this is your basic understanding of this. So what I will do is I'll keep this as, okay, go to pattern, yes, continue. Right. Now we will extend this topic to little ahead. Fine. This is calling subroutine, uh, provision. Then this is your like okay. Suppose I will go to perform subroutine 1 directly. I will use the name as subroutine 1. Right. Perform subroutine 1. I am trying to call, only calling statement. So subroutine 1 does not exist. Now, subroutine subroutine can be created, subroutine can be created by forward navigation also. Subroutine can be created by forward navigation. Yes. So, forward navigation it double click. Okay, forward navigation. Suppose if I double click on subroutine 1, because see the above below demonstration, you have to observe closely. First, I defined subroutine. Later, I specified the calling statements, correct? Reusability concept, avoiding code redundancy, nested concept. Here, actually, we can go for Recursive calling also we can check. What is the meaning of recursion? Recursion is this. Like if you go to test subroutine statement, yes. Okay, again inside I will write perform sub one. So whether this is syntactically correct, it is syntactically correct, but still it doesn't give any output because this write statement generally it should give output, but write is not open outside write. Write is there between inside form and form. So first of all, you have to call this subroutine once at least outside. So then it works. Okay, we will see now. What is this? Okay, this is execute now. It is going to runtime error. This is called as a self-calling or recursive calling. So why it goes to dump or short dump or runtime error, we will evaluate. First of all, see how this program execution flow sequence perform sub 1, right? Perform sub 1. When we say perform sub 1, control transfer to form sub 1. Correct? It will start executing all the statements till end form. It will go to till end form. First write statement, after that perform sub 1, right? Perform sub 1 means it calls itself. It calls itself, itself. That is, it is keep on writing test subroutine statement multiple times. When it will go terminate, no. There is no point of terminating here. It is not getting terminated. See, here it is abaption is terminated. Internal task error handling system message. SAP HANA error. So that is even it's showing dump also. The dump reason, see, however, we have not get the output. So if not getting output, there is something error. What is that error? If you want to go to debugger, we'll come to know. Because if you always debugger is the best way to evaluate the error. So let's see first in debugger. Program menu, execute debugging. Right. Go to desktop 3 for clarity sake. Zoom in. Since everything code is commented, cursor is there at report statement. Line number 6. You just only use this F5 concept. F5. F5 is only F5. Perform statement. So perform sub 1. Yes, it control jump to form sub 1. Right. So it is writing write statement. Okay, but we cannot see that write statement result here. In old debugger, there was a buffer we used to see that small internal buffer. Then go to perform internal list buffer. So perform sub 1. So it calls itself. Next perform sub 1. It calls itself. That is, it is calling itself means write statement followed by perform statement. Again, it calls itself. So it never ever going to, yes, it is. See, here also, it is not showing the event. It is showing all the statements between. That is, this perform statement is also a part of the between form and form. It is it acts like a normal statement calling to the same subroutine. So it calls itself for several times. It is never going to terminate. But then what will be the result? After few minutes, it will go to runtime error. Because it is keep on writing test subroutine one side, test subroutine statement multiple times. But at one point of time, it will go to, this session got some time limit to execute. Let's say 1 minute equals to 60 seconds. If the program is executed within 60 seconds is okay. If it is exceeding 60 seconds, automatically it leads to runtime error stating that the timeout error. Okay, so you can see after few minutes, you will get same error also. Okay, so this is Yes. No more memory available to add rows to an internal table. So runtime error description. Okay. Runtime error, you want to short description, long description. So that's not showing here. It's okay. So overall, whatever I said, that is true. So self-calling is possible. Yes, it is possible. But finally, it leads to timeout error, runtime error, dump, short dump. That's why never call the subroutine. Subroutine itself. Right. Then okay. Like uh, what next? Suppose perform sub one, this calling statement existed multiple times. But the subroutine, same subroutine can exist multiple times? No. This is error again. Sub one already exists. This is another. Each subroutine, each subroutine name must be unique, unique within the program. So what does it mean? That is, each subroutine, okay, must be okay. Defined by unique name. Okay, based on how do you do that? Based on its functionality, we will do the naming convention. Based on functionality means what it does. Accordingly, we will go for next. Okay, by unique name. Subroutine must be defined by unique name. Okay, second. Like duplicate subroutine names not allowed. So that is I want to not allowed within same program. That is, so obviously I have to go with different names, right? So like suppose I will convert it into subroutine 2. Subroutine 2. Okay. Yes. Now it is accept. Okay. So what is mandatory in this case is subroutine 2 exists, but I'm not calling. That's okay. So subroutine, yes, everything we have to note it down. Subroutine definition can exist without even calling statement. Without even calling statement. Okay. Yes. But perform statement perform statement cannot exist without subroutine definition within program. Everything we are talking on within program only. So you have to understand each line. So I'll go for this. Suppose subroutine 2. Okay, I will write here as some skip perform subroutine 2. So subroutine 2, both are there, it is accepted. But if subroutine calling statement I comment it, it is accepted. But can I do it vice versa? Calling statement I'll uncomment it. Under the subroutine definition I'll comment it. Now you will get an error. Because as per basic why it is getting error, you can see the form sub 2. See here it is the form. They are calling it as form only. The form sub 2 does not exist, but there is a form with the similar statement sub 1. So the system is proposing for that. There is a auto correction symbol is there. That is, it is going to, if you continue, it will convert into sub 1 automatically. I repeat, check, it is converted to automatic. This is the system do it help for you. But no, I want to do subroutine 2 only. Subroutine 2, still error remains same. So what I said, if you want to call a subroutine, its definition must be there anywhere in the program. Because what is this? When the in the control comes to perform sub 2, what system is looks for? Where is this subroutine definition? Where is this subroutine definition statement? Yes, yes. It will start line by line. Wherever this sub two 4 letters match with these 4 letters, then it will go inside of the form. It will continue all the statement. It can be 1 line, 2 line, 10 line, 100 lines code. It will execute all the statements as a structured sequentially line by line, and finally at the end form it will ends the subroutine. End form ends the subroutine. It begins, it ends. Okay. Yes. Now, what are the rule? Subroutine. Subroutine can be defined as empty also. Empty means no statement between form and end form. That is valid. Or subroutine can be defined with single or multiple statements, multiple executable statements. Okay. Executable statements. Yes. Next, subroutine may have some logic. Okay. Logic to perform okay, some set of action. Yes. Like subroutine can be used to perform particular unique operation. So these are all the equivalent statements subroutines are used. All are same. But going forward, I will try to give clarity on all these things. Right. Okay, got it? Yes, wantedly I demonstrated. Yes. Even though it is empty also, still control goes there. It will try to execute all the statements till end form. Okay. Yes, it could be empty. This is your basic. Next, I am going to use this subroutine. Okay. Subroutine generally ends with end form. What is the meaning of that? That means system executes all the statements, okay, all the statements till end form, right? Till end form. But there is a exception to that. But we can terminate subroutine explicitly. Explicitly means yes, as per our requirement, wantedly. That is explicitly means not by this end form is automatically, which SAP does that. Explicit means we can explicitly terminate the subroutine with check statement with the check statement or the exit statement. Okay, or exit statements. So now, yes, check statement is used to terminate subroutine conditionally, conditional termination. But exit statement is used to terminate subroutine unconditionally. This is, we already done conditional termination and unconditional termination in do loop, isn't it? Similarly, suppose, what is the meaning of that? Okay, we want, we can test it here. Suppose subroutine 2, okay, subroutine 2 between, yeah, we have, yes, write something like that, test 1. We will see write test 1, write test 2, write test 2, test 1 and test 2, correct? Yes. Oh, we will go for, see, I don't want, observe now, if you execute, you are getting the output like this, test sub 1, sub 2 and all. But I will comment this calling subroutines. Yes. Calling subroutines, you comment it. That's all. Control never goes to this statement. Yes. See, now you don't get the output of this. You will get the output of, yes, test 1, test 2 only. Observe it. Because even it is a part of the code, but at least one calling statement is required to test, isn't it? If it is not exist calling statement, it never goes to. Then come to the test subroutine test 1 and test 2. This is your normal approach, correct? But now in between, I'm going to add one check statement. Check 1 equals to 1. Yes, 1 equals to 1 is true, right? That's why you will get output as test 1 and test 2. Okay. Yes. Now I'll comment it. Then check 1 equals to 2. Okay. And 1 ever never is going to equal to 2. That's why you will get output as test 1 only. So you have to catch this. See, I repeat it. First control comes to skip statement. That's okay. System writes blank line, perform sub 2. So sub 2 means directly controls looks to sub 2. First it will write test 1. Then it will go for check statement 1 to 1 is true. That's why earlier it was written this one, write test 2, end form, till end form. Right. But when I add a condition with a invalid condition, that is 1 is never going to be equal to 2 in nature. Okay. So what happens, how it is getting executed is, this time also you can debug this time, so that you will come to know. Debugger gives much more clarity rather than me to explain this approach. So go to here, skip statement, okay, general statement. Now here it is perform sub 2. Perform sub 2 means control jump to sub 2. Yes, first write statement is okay. Now it is going to check. If this check is a keyword, you don't require end check. Okay. Check followed by condition or expression, you can write it. If this condition is true, then the following statements gets executed. If the condition is false, directly control goes to end form. This is what you have to observe. Yes, end form. So the result is only you will get test one only. Clear? Yes, this is one thing. But I want to use, yes, I want to use exit here. Exit. So when you write exit, exit is a statement. Exit is a keyword come statement written between form and form. So now the result is just one. Okay, we will see the differences between this because we can, yes, if, okay, if the check statement means check condition statement is true, is true, then, hmm, then uh, system executes, system executes all the statements, okay, till end form. All the statements till end form. Correct? Right. Next, if the what next? If the check statement, check condition, check condition statement is false, what happen? Then control transfer to end form directly. End form directly. This is called as conditional based termination. Condition to execute. If condition false, directly exit. But if what next? If system come come across exit statement, exit is a keyword come statement. Exit should be written as independent. Exit followed by you should not write anything. But check followed by you can write a conditional expression. That's the difference between check and exit. If system come across exit statement within subroutine definition, yes. Now it immediately terminates the subroutine. It immediately terminates the subroutine, okay, and control transfer to end form. Transfers to end form. That means, what is the meaning of this? Yes. Okay, is when exit means just like a immediate termination, permanent termination. It never execute. Exit followed by whatever you write it, control never goes whatever is written after exit. Okay. So you have to know, I repeat once again, if you don't write a check or exit within subroutine, normally it will execute it till end form. That means the subroutine generally ends with end form. Ends with end form. Correct? Ends with end form. But you want to explicitly terminate the subroutine, there are two keywords can be used. Check and exit. Check for conditional termination, exit for unconditional termination. Right? So, because I just demonstrated both, you can uncomment and check my code. Okay? Yes. But in a large size code also, you can use this check and exit inside this. Clear? So these are all part of basic only. We are still into introductory part only. Introductory part. Okay. Right. I'm going to comment this uh, because sometimes this is a question, how do you terminate the subroutine? Okay, it is good to have. I covered randomly. Now I'm going to another one. Yes, subroutine. Test subroutine 1. You will get subroutine 1 does not exist. Subroutine 1 does not. So now what we can do is double click on this subroutine name. Double click on subroutine name. Double click. Subroutine does not. Do you want to create the object? Yes. Okay. Program change. Do you want to save before exiting and editing? Yes. Continue. Time being, select the main program. Select the main program. Because system is create subroutine. Because as I said, subroutine, first you define it and later come back to call. Okay. Otherwise, first I am calling without definition. Obviously, it gives you error. Okay. So you have to create a subroutine. Subroutine you can create by forward navigation. Forward navigation will double click on the name of the subroutine. It will ask for, does not do you want to create? Yes, proceed. There is a one dialog box with the title create subroutine. This is the name of the subroutine. Now there is a include selection in that. Under include selection, system is giving some K program subroutine. Yes, this is the name. Include. Okay, name of the new include F01 include system is proposing. That F01 part late default it is selected there. But I am switching to main program. That is select the main program or master program. Continue. So as a result, what happens? As a result, what happens? System generates a template for you. System generates a template for you. Right? What is this template is all about? So here, this is the commented section. That is here you can write the subroutine text, purpose or functionality, you can write it here. The next, this is incoming arrow. This is outgoing arrow. There is P1 means formal parameter 1. P2 formal parameter 2. Formal parameter name and its corresponding text. What it does? Formal parameter 2 and its corresponding text. You can write it. Okay. So go to yes. Execute. Execute. See, even it is neither syntax error nor runtime error, but no output also. If you want to display output, at least one test uline statement or skip statement or write statement is required because even you want to go to the output. Yes, it is writing this underline. Okay. Otherwise, at least go to skip. Skip also will take it to the output. Hmm? Skip also take it to the output. Otherwise, go to write statement. Write statement. Yes. Test subroutine 1. Test subroutine 1. That's it. So activate. Do not forget to activate for every chili. Now, you are getting the output. Okay. So to display something, at least one write statement or uline or skip statement is required. Okay. That's okay. So now, as calling several times, reusability of the source code and all I explained. But we even this system generated this template, you can keep it or you can delete it also. So that again I am going back, subroutine 1, subroutine 1. This should accurate, it should tally. Because when you create it, there is a typing mistake might happen. That's the best practice. What we will do is, we will go for like uh, by forward navigation is the best approach. Okay. Then next, suppose after end form, I will try to write ABC. So try to write ABC. So it is giving error. Error is statement is not accessible. So after subroutine definition, general statements are not allowed as center. Okay. That is, I want to print after test subroutine, I want to print ABC. So that is, if I keep it inside, now it is accepted. So you are getting this. Okay, right. But if I keep it inside, what is the problem if I call twice suppose? Every time I will get test subroutine 1 and ABC. Test subroutine 1 ABC. But I don't want that ABC should come for every time. Then remove this. You keep this right ABC after subroutine. Right ABC after subroutine. What is the difference you have to observe? So now what happens? ABC appears only one time in the out. This one time in the out. But output seems like same because what happened? First perform subroutine. Then it will go to subroutine 1. It will execute this right statement. Inform, after inform, it ends the subroutine. After inform, control returns to this place again. It will go to the next immediate statement. It will execute all the calling area statements. All the calling area statements. Now, finally, it ends the program. This is what. So, coming back to, suppose if I keep it here, same statement, even though now if you test it, ABC appears only one time in the output. That is, if you are expecting the ABC to be available for every subroutine call, don't write outside then. Write inside subroutine. Okay, got it? Then that is exactly what exactly your requirement. Accordingly, we can. Okay, got it? Then next, we have to discuss the second part, which is very important, subroutine 2. Subroutine 2 does not exist, but you can create a subroutine by forward navigation. But when you create a subroutine by forward navigation, yes. Do you want to create it? Yes. Like automatically, system creates, choose master program. Because this is subroutine 2, choose master program. So system automatically creates a new subroutine, okay, after existing subroutine, right? So this is what you have to understand. Here inside, now I can go and write paste, okay, subroutine 2, right? Now, okay, so here, this is the output. Test subroutine 1, ABC, test subroutine 2. So, what is the meaning is, like this sequence, actually the calling sequence may differs for the existing sequence. That is, like, yes, subroutines can be called in any sequence, irrespective of its existence. Is very important. Okay, yes. So subroutine definitions can be in any sequence, can be available, can exist in any sequence. Sequence means order. Okay, that means it need not to be the same calling order, and the subroutine definitions order doesn't require to should be match. It can be any order, but still it should be there within the program. That's it. It will give the output. So this is about your basic introduction of subroutine only. Still, I need to introduce a lot of fundamentals only. We are into this. So we'll continue the next session. Okay, later. Thank you.